I'm Mike O'Neill and welcome to FlyBoyz. So back this summer I did a FlyBoyz post relating to a Sinbad glider that I'm building. I'm taking an old Berkeley Sinbad free flight glider and doing a conversion of it into a 3-channel radio control plane. At that time I indicated that I was hoping to have the plane built and ready to fly at the NEAT Fair, which is held down in the Catskill region of New York State in mid-September. Here it is early December, and to no one's surprise, the plane is not ready. I did not have it in time for the NEAT Fair, and at the rate that I'm going, I may not have it in time for the 2018 edition of the NEAT Fair. Hopefully that won't be the case. So currently 6 months have elapsed since I started construction on the plane on June 4th. And over that 6 months, I've invested a grand total of 76 man-hours in the construction of it. So as you can see, I'm not making real good headway on it. It's due primarily to the usual excuses that I have, which primarily is a full-time job, which consumes 50 plus hours of any given week of mine. So I really need to retire in order to be able to work on my planes. There's also a lot of house construction and renovations that are still going on, both inside and outside of our house. And I have family commitments like anybody else. And then things like going out of state for 10 days on a business trip interferes with plane building. It's kind of hard to be building planes when you're out of state on the road for 10 days. So all that's conspired against me, and here it is, early December, and I'm still nowhere near where I wanted to be on the plane at this point in time. That aside, I did want to provide an update as to what I have been able to accomplish since the last video. And it's just been a litany of one issue after another. In no particular order, I've had a lot of issues with the ESC, which is the engine speed controller for the motor. I've had wiring issues, I've had engine pod issues, I've had various construction issues, and I've had a lot of covering issues. And what I want to do is highlight each one of those as to what's been involved in trying to do this conversion. And by the way, I'm not setting a new completion date on this airplane. Right now it's just going to get finished when it gets finished. So back to what the build issues were. The first one that came up was the ESC. The ESC is a very small little electronic component. It's the engine speed controller for the electric engine or motor that goes along with the plane. It turns out that once we had everything installed and hooked up, that I had a bad ESC. It wasn't working all the time. It was erratic. And so I ended up having to purchase a new ESC, which wouldn't have been a problem, except the ESC that I had was for a brushed motor. And that's what I had with the plane, was a brushed motor. We weren't able to find any brushed ESCs. So we ended up buying an ESC for a brushless motor, which that also meant that I had to switch out the motor from the brushed motor to a brushless motor. Not necessarily a problem, except the size motor I needed was only available from a supplier in China. So I literally had to wait for a slow boat from China to get the motor to be able to proceed on that front. The old motor was firmly installed in the engine pod that I had built, and removing it from the engine pod would have meant the destruction of the engine pod. So that meant that I had to get a new engine pod, and I'll show you all this as I go along in the video. I needed to get a new engine pod and build a new engine pod to hold the new brushless motor that would now connect to the brushless ESC that I had. So that turned into a bit of a fiasco, and that consumed a lot of time waiting for all the shipping and everything to transpire on all that. Once I got the new ESC and the new motor, discovered that they primarily didn't have any connectors with them like the original ones had, and that required soldering connectors onto the new motor in the ESC. not necessarily a problem, except I have no soldering tools and no experience with soldering. So throughout all this, one of the guys from my local STARS, the Syracuse Thunderbirds Aero Radio Society, that's the RC club I belong to, one of the guys, Michael Graham, has been of invaluable help to me in first diagnosing all the issues that I've had and then helping me work through them. So Mike came to my rescue when it came to soldering on connectors onto the ESC and the motor, and we spent a lovely evening in his basement one night soldering all the connectors that needed to go on. So I want to thank Mike for all his help. He's been gracious in helping me through all this. This also meant that the original ESC to the motor, the wiring from the ESC to the motor had to be removed from the plane and new wiring routed, and that required some little adjustments to the construction of the plane in order to rip out the old wires and put new wires in. So as far as the engine pod, I indicated that the old motor was permanently attached to the engine pod, so I had to get a new engine pod. Once again, had to order that, and fortunately that built up in an hour or two, so the new pod was not really an issue. I installed the motor in it, and that still needs to have the covering applied, and I'll get to the covering situation in just a minute. I then still have to attach the engine pod with the motor to the wings, and I still have to figure out a little bit of the engineering as to how that's going to happen, because that's not part of the original design of the plane. So as far as the construction of the plane, I have been able to complete most of the construction. I've still got a little wing work left. I've got to attach the engine pod, as I just mentioned. I've got to sheet the leading edges, and then I've got to attach the two halves of the wings together. And then finally I have to sand the wings, and I have to do a final sanding of the fuselage also. And so with all that being said, that brings me to the covering. I wanted to cover this plane with a transparent covering so I could see the structure, so I decided not to do tissue or silk span as the covering. Instead, I went with Microlite, which is an iron-on product like Monocoat. However, it's very thin and very, very lightweight, which would be fine for this application on the glider. And it had some transparent colors available. So I went with the Microlite, which I've never worked with before, and now that I've got some experience with it, I will never work with it again. For those that aren't familiar with Microlite, it's a very, very thin product. It's very similar to Saran Wrap, and if anybody's worked with Saran Wrap before, you'll know what I'm talking about here. I've found it very difficult to work with, and since I've never worked with it before, I don't know any tricks of the trade, which others may be familiar with, as to how to work with it. What's made it worse is with my shaky hands and bad eyes, it's compounded the situation of trying to work with it. So what are the issues? Well, as I said, it's extremely thin, and as a result, it's very hard to cut or trim it after it's been installed. The biggest issue is that it sticks to itself. If you've used Saran Wrap, you know that if you fold it over onto itself, it sticks to itself, and good luck trying to get the two pieces pulled apart. Well, Microlite works exactly the same way. If you by some chance accidentally fold it over onto itself, good luck getting it unstuck, and basically you just throw that piece away and start over again. So it's been very difficult to work with, and as a result, it's taken me a very long time to do any covering with it. I also ran into an issue where I have a regular Monocoat iron, and that was just too big for the surfaces that I'm trying to cover here, and all the joints and the crevices and the edges and everything else. The Monocoat iron was just too big. So I ended up having to go out and buy a trim Monocoat iron, which is much smaller, and I find that that's been very, very good to use with this. However, I did run into a problem with that, and that is the Microlite is very sensitive to the temperature of any of the irons that you use to apply it with, and I didn't have anything to measure the temperature of the iron with since they're not marked with a temperature gauge on them. So I went out and I purchased a laser thermometer, which I'll show you a little bit later. And actually that's worked out very good for determining the temperature of the irons that I'm using. So when I tried to install the microlight, as I said, it sticks to itself. Some of the parts that I'm covering here, you have to cover both sides, for instance, of the rudder, but there's only 3/32 of an inch between one side of the rudder and the other. And once you apply the microlight to the two sides, if you happen to accidentally touch the surfaces together, they're stuck permanently, and I'll show you a little bit of that in the video here in a few minutes. So the surfaces that I've covered so far, for the most part, do look very good, and I've been able to get everything covered without introducing any warps whatsoever into the surfaces that I've covered so far. And that to me was extremely important, that I build a warp-free plane. So I'm very happy with that. Then finally, the other issue, the last issue that I've run into with the build is the engineering that I've needed to do as I go along here. As I mentioned in the first video, I am not an engineer, so engineering things is difficult for me. You give me a set of plans and I can pretty much build anything, but don't ask me to engineer it in the first place. So as I've been building and assembling this glider, I realize little things that need to be re-engineered to accommodate both the engine pod and the radio control gear that I've installed. And so I'll show you, as I move the video over to the plane, I'll show you some of the minor engineering tweaks that I've made. Again, these would be no big deal for most people, but for me, it's kind of a big deal. And so I've been kind of engineering this thing as I go along. So that's where it is right at the moment. That's what the state of these delays is all about. And I'm just going to keep plugging along on this thing until I finally finish it, whenever that may be. So right now I'm going to switch this video over to the workbench and show you some of what I've been talking about. Okay, here we are over at the workbench with the various parts of the Sinbad, and for the most part, most of them may not look a whole lot different from the last time we did a video here. But what I want to do is walk through some of the changes that have happened since the last video. And I'm going to start on the fuselage here with the ESC. Now the ESC, this is not the original one. This is the replacement ESC that the original one went bad, as I mentioned, and we had to put a new one in. We had to solder the connectors on, and you can see where the solder joints are here. We've got them covered with shrink wrap tubing. And then the wiring went through the bulkhead and came out this side over here. And we had to do some drilling. There you can see it right here. We had to do some drilling through the platform here to get the old connectors out and the new ones in. So this represents new electronics in this area here. I'll come back to the glider fuselage here in just a minute. I'm going to switch over to the engine pod. And this was the original engine pod with the brushed motor on it. And as I said, the ESC that we had was for a brushed motor, and we couldn't find an ESC for a brushed motor, so we had to switch to a brushless ESC, which meant switching to a brushless motor. And this motor is very securely attached in here, so pulling it out would have meant ripping this whole engine pod apart. So what I did was I purchased both a new motor and a new engine pod. So here's the new motor and the new engine pod that it's mounted in. Again, the new motor came with no connectors on it, so you can see where we've done some wiring to get the new connectors on, got them all covered with heat shrink. And again, my kudos to Mike Graham for all his efforts at doing this soldering and getting everything wired up here so we're ready to go. So that's what's going on with the ESCs. We basically have a new ESC, we have a new engine pod, and we have a new motor, and we have all the soldering. So hopefully we're ready to go on the electronics end at this point. As far as construction, I indicated that we're mostly done in construction. I've got the 2 wing halves built. I didn't have wings the last time in the video, so we've got the 2 wing halves. There's one there, and here's the other one here. And these are all ready to be connected together. The engine pod, hopefully you can see this on the video as I demonstrate it. The engine pod will sit in here, and I have to engineer exactly how that's going to happen. Let me get the fuselage out of the way here. I will have to engineer exactly how this is going to connect such that the wiring harness can go down through the fuselage and so forth. So I've got to finish that up, and we've got the sheeting here which goes over the leading edge of the wing, and I'm waiting to put that on until after I get the engine pod situation all figured out. And then the 2 wing halves will be glued together, and here's one of the braces for that. So that's where the wings are at this point in time. Switching over to the tail feathers, I've got the rudder all built, and here is showing some of the microlight covering that I did. And if you notice how thin this rudder is, it's about 1/16 of an inch, maybe 3/32 of an inch thick. So when you cover one side and then cover the other side with the microlight, you don't want to pinch together where this covering is, and that's what I have accidentally done here. I don't know if you can see it on here. There, if I can get the light on it, you can see right there I've got a pinch, and right here I've got a pinch. This is where the microlight on one side has stuck to the microlight on the other side, and I have tried various methods to unstick these two. And if somebody knows a way to do that, I would really appreciate you contacting me through FlyBoyz and letting me know how I can unstick those two, because right now they are stuck together. The microlight itself covers very nice. It's got a nice transparent look to it, which is what I was looking for. The rudder is not glued on yet. It's just set in here because I still have to do some more work on the attachment points of the rudder. But here's a situation where, again, a little tiny thing that I didn't realize at first. I had to do some engineering, and that was I had to add a control horn to make the rudder operate. And so I added a little gusset inside here. You can see it through the covering. I've added a little gusset to reinforce the point where the control horn is attached. In an earlier video, I talked about how I made these side supports thicker to accept the hinges, and you can see how the hinges are glued in these 3 spots. They're not glued in on the vertical stabilizer part yet, but that's how the rudder's going to attach. So that's where the rudder is. Okay, now moving over to the elevator. Here is the elevator here, which has been covered. And as you can see, so far I haven't managed to stick any of the sections to each other, so that's real good. This is really thin, as you can see, but they've managed to not stick together. And hopefully you can see that I've managed to maintain a very warp-free structure in the process of covering them. Just as in the rudder, I had to add a gusset in here to strengthen the area where the control horn goes in. So that's where I am with the stabilizer. The fuselage is pretty much the same as you saw it last time. I have added a platform for the stabilizer elevator attachment because all it originally had was just a 3/32 inch stringer on there, and that wasn't going to be enough to give me a good secure attachment point for the stabilizers. So I built out this platform here. At the same time, I realized that now that I have a movable elevator, the cross section on the 2 elevators needed a place to move, so I had to cut out, if you can see here, I had to cut out a little bit of an angle here, not a big deal, but that also meant I had to put a reinforcement gusset in here to add some strength. So this is an example of the little type of engineering changes that I've had to work up to accommodate the RC gear. I talked about the microlight. Here it is, Coverite microlight. I don't know if you'll be able to see this, but it is extremely thin. And what you're looking at here is the microlight with the backing still on it. Once you peel off the backing, this thing is even thinner than it is right here in the video. And like I say, it's like working with saran wrap once it's all ready to go. Right now you can lay it over on itself and it's no problem, but you take the backing off, and if you were to do this, it would be a throwaway piece because it would all be stuck together at that point. And then I talked about having to purchase a new monocoat iron, and I got this nice little trim monocoat iron, which comes with two different points, trim points for getting in all the little fillets, the nooks, the crevices, the joints and everything. And this just works really good on the small surfaces that I'm dealing with, and the microlight. It works very good with the microlight. But again, as I said, while it does have a thermostat for controlling the heat, there's no indicator as to what the heat is. So what I've had to do is, I mentioned this device. I went out and I went to Harbor Freight, which is a great store, and I got this Centec infrared thermometer. This was all in $19.95 at Harbor Freight, and it allows you to, and let me turn it on here, there we go, and do this in Fahrenheit as opposed to Celsius. Once you get it turned on, you just point it at the surface that you want to measure the temperature of, and you can see the little, well, I don't know if you can see it in the video. If I get it in the video, it might help. You can see the little laser light on the surface of the monocoat iron there, and right now it's measuring 69.8 degrees. And so I just turn the monocoat iron up to the temperature that I want, and measure that temperature with the infrared, and I am able to control my temperature accordingly. So this has been a lifesaver as far as putting the microlight covering on, and this infrared thermometer from Harbor Freight has been good as far as controlling the temperature that I'm using. So I'd highly recommend this. For 20 bucks, it's been a great tool. So that's pretty much everything that I want to show at this point. You can see there's still a bit to go here. I've got to do a lot of sanding on the fuselage, got to finish construction of the wings, sand the wings. Then I've got to cover everything. Covering this engine pod is going to be no joy. I tried to cover the first one and ripped it all apart because it was almost impossible with the big monocoat iron. Now with the little trim iron, hopefully I'll be able to get the microlight around all these compound surfaces with no big deal. So that has to be covered, and then we have to do a final assembly of everything, and hopefully then we'll be ready to fly. So that's where we are right now on the construction, and I'm going to go ahead and go back to the main bench at this point. And so there you have it. That's the current status of my Sinbad conversion build. And as I indicated earlier in this video, I'm not going to predict a completion date on the Sinbad at this point. I'm just going to keep plodding along on it until ultimately it's done. I would hope that it'll be done for the spring flying season, but we'll see. And in part, it may be delayed even more because I'm going to be multitasking it with another build at this time. I had talked in an earlier video about my priorities on building planes, and Sinbad was number one. I also talked about constructing a SIG twister control line plane as my second priority build. And given that it's December and I want to have the twister ready for the spring flying season, that means that I need to get going on building it also. So the SIG twister is right here. This is the kit that I'm talking about. I'm going to be setting this up momentarily and starting the construction of it. and I'll have this going on one workbench, and I'll have the Sinbad going on the other workbench, and I'll try to keep both builds going at the same time. I will be on the Twister doing a little different video and reporting format on it, in that my control line flying buddy Steve Dwyer is also building a Twister, and we're going to be building them at the same time. There's differences in what we're going to be doing to each of our builds, and so we're going to document the two builds at the same time and highlight some of the differences between them. And then come in the spring, when we get to fly them, we'll see how those differences translate into different flight performance out on the flying field. So hopefully that'll be an interesting series of videos and FlyBoyz posts as we both progress on our Twister builds over the winter time. Again, in the meantime here, going back to the Sinbad, I really want to give recognition and a lot of thanks to Michael Graham, who I talked about earlier. Mike has been a great supporter of me on this Sinbad RC conversion, and he's waiting in the wings at any given time to help me with my next hurdle that I have to overcome. Right now, he's focused on making sure that I get all my batteries properly charged for both the transmitter and the receiver in the plane, and so he's been fun to work with in this regard. So again, I want to thank Mike for all his help on the glider. So that's it for this video post. There will be another one on the Twister. Hopefully that might be the final construction one where I get to show you a completed plane, and then we'll switch over to maybe even having some videos of it flying. So that's where we're at. Thank you, everyone. I appreciate you tuning in here, and we'll see you next time on FlyBoyz. Take care.